Friends, in the series of C programming, till now we discuss operator types. In last video, we discussed what is arithmetical operator, what is relational operator. Now here in this video, we're going to discuss next operator type, that is bitwise operators in C programming. So let's start. Now, bitwise operators are nothing but the operator which act on bits. Now we know that arithmetical logical unit, which is in CPU, so all mathematical operations like addition, subtraction, multiplication and divisions are done on bit level. That's why it is called as a bitwise operator. Now let's understand bitwise operations in programming, which are called as a bitwise AND, bitwise OR, which is indicated by this sign. Now this is bitwise XOR, bitwise complement, bitwise left shift and bitwise right shift. Now let's discuss one by one all these bitwise operator. Now this operator appears like logical operator, but it's not a logical operator. So let's first understand what is mean by bitwise AND operator. Now it represent by X and Y. Now if we give the input X and Y as 0 0 0 1 1 0 1 1, then output of bitwise operator is always appear 1 if the corresponding bits are equal. That is, if the corresponding bit is 1 1, then it gives the output as a 1. Otherwise, if the rest of bits are the 0, so result of corresponding bit equivalent to 0 if the either bit is or one of the bit is an 0. So let's understand it with one example. As it acts on bit, so you must know how to convert decimal to binary, and it is represented as a 8-bit pattern. Now first understand to try decimal to binary number, because we divide 12 by 2 because we have to convert it binary, and we will going to consider as a reminder from bottom to top. So decimal number of binary 12 and decimal number of binary 25 will get the bit operation 12 and 25 as, and will perform an AND operation. Now we're going to check the corresponding bits of these two binary. That's why it is called the bitwise operator. Now according to our X and Y truth table, if there is a 1 1, then we'll get the output as a 1. Now rest of the, now here will corresponding bit is 1 1 and rest of the bits are the 0. So the result of this 12 and 25 is nothing but decimal 8. Now let's understand what is mean by bitwise OR. Now similarly, and if we consider the X or Y, will get the 1 1 1 for 0 if we have a 0 and 0 and 1 1, and if we have 0 0, that is similar bit, will get the 0. So 12 or 25, so we'll get the result as a 1 1 1 0 1, which is equivalent to 29 in decimal. Now here, as we know that all ones, if 0 0 is the input equal or corresponding 0 0 will get the 0, otherwise will rest of the bits result is the 1. So we'll get result of OR, that is 29. So let's understand next bitwise XOR operation. Now here in this table you can observe XOR operator if 1, the corresponding bit of two operator are opposite. Now if we have the opposite 0 1 or 1 0, then we'll get the 1 1 result in XOR. Otherwise, if there is same input, we'll get 0. Now let again understand this with one example. If we make the XOR operation for 12 and 25, we'll get the result as a 1 0 1 0 1, because if we have 0 0, we'll get result 0. if we have the opposite operands, we'll get always the result as a 1 1. So we'll get the decimal answer as a 21. Now let's see what is meant by complement operator. Now complement operator is apply on unary operator, that is one single operand, unary that is 1, and it complement, that is it's going to change from 1 to 0 and 0 to 1, and it is denoted by this signature. Now suppose 35 is a binary number, so we'll going to make the complement as a we change this 0 to 1 and 1 to 0. So we'll get the answer like this. 0 get changed to 1, again this 1 is get changed to 0. So we'll get the answer in 2 to 0 in decimal. So this is the bitwise complement operator. Now let's understand what is mean by shift operator. Now shift operator, that is we're going to shift the bit. Now there are two shift operator in C programming. The first is the right shift and left shift. So let's understand one by one what is left shift and what is right shift. Now let's first understand what is mean by left shift operator. Now here in this diagram you can observe left shift operator, that is we are going to shift the bit as left side. Now this is the bit 10101. Now here if I shift this bit as a 1 byte, or if I shift this bits as a 1 bit, so this one, the first one, because we have to shift as 1 bit, so this one get discarded. So this first one get discarded, and the next bit as a 0 is going to make occupy in the next block. That is this 0 is get here, this 1 is placed here, 0 is placed here, 1 0, and 1 bit is discarded. So at last we have to insert 1 0. So left shift operator, that is it shift all bits to our left side and certain numbers of specific bit. If I shifted 1 bit, so I can represent it by this signature, that is if I shifted 1. So bit position have been vacated by the left side operator and it is filled by the 0. So I have to add 0 at the last, and from the left side I have to discard the bit sides. Let's see the example here. Now 212 is in binary, and if I shifted at the left side 1, so if I shift this left side 1, so first this is the left side, so this first one get discarded and remaining bits, I'll get this remaining bits, as at last this is the 20, I have to insert one more 0 because this first bit is get discarded, and finally I'll get this answer after left shift by 1 bit. So this is the left shift operator. Now let's understand what is mean by right shift operator. Now similarly left shift operator here will going to shift at a right side, and if I shifted 1 bit from right side, so the first right side bit get discarded and I have to add 0 at the last. So this one get discarded and this next all bit get shifted to the next position by right side only. That's why it is called as a right shift operator. Now this bit shifted towards the right with certain specified number, and this is the denoted, or this is the sign of denotion. Now 212, this is the binary number, and if I shifted as a 2 bits, so at the right side these 2 zeros from this right side I get discarded, and remaining these bits I can put 20 at the last. So this is called as a right shift by 2 bits. Now 212, that is this number, I'll get this I will shifted by 7. Then all these 7 bits get discarded and only remains 1, and I have to put the all 70 at the last because it's an 8-bit representation. Now if I shifted as a 8, so total 8-bit I'm going to shift it at right, so no bits remain, so I'll get the answer as a 0. If I shifted by 0, there is a no shift. So this is all about the right shift operator, and this is all about the bitwise operator, which having the bitwise AND, bitwise OR, bitwise XOR, and left shift and right shift operator. So this is all about the bitwise operator. Now in next video we are going to discuss what is meant by logical operator. Thank you.